Hi all, I'm Dikshatnika. Now I'm going to present my project real-time multi-modal intent classification using BERT and advanced data augmentation. And my supervisor is Dr. K. Praveen Kumar Garu. This project introduces 1 minute. So these are my contents, and this project introduces intentify, like means when you give some same input in different possible ways, it gives the accurate same output for both voice and text. And I built it using BERT model to handle multi-modal data and give strong performance. And I have applied smart data augmentation methods, identify like I identify achieves good accuracy, and this model is capable of recognizing 9 different intent types and provides a confidence score. Like I have did it using 9 intents, and the practical outputs shows that my bird based model performs better than traditional other NLP techniques, and multi-modal gives smooth and responsive voice to intent detection. And intentify is and when we go to introduction, the intentify is main part of AI systems. It helps virtual assistants to understand what what users want and responds appropriately. And combining BERT with voice and text inputs is still a challenge in current research papers, uh, whatever I saw. And to solve this, I have introduced Intentify, a smart intent classification like that, which includes BERT architecture and multimodal intent support, advanced data augmentation, and real-time performances also. And I have found these papers, like previously they have used Navi based classifier for text categorization, and they concluded that its performance depends on how text features modeled, and how they used multi-modal for representing words occurrences in documents was more effective, especially for longer text, like longer sentences. Then I found some other paper, like which in which they have introduced CNN, convolutional neural networks. They concluded that CNN will automatically capture important patterns and features in text with more flexibility and powerful than older approaches, like older models. And uh, using BERT also, I found some other paper, uh, like where but they did it only for text classification. They explored more on how best we can tune BERT for text classification. um, that is the existing system. And in the proposed system, what I have implemented is using BERT model. I have created for accurate intent detection for both text and voice. And along with that, I have introduced multimodal intent classification system also. And speech recognition will convert voice to text, and the outputs will predict the intent based on confidence score. And the data augmentation for is you I have used it for better performance and design, and I have designed it for real time applications. And the methodologies I have used in this are intent classification, like where intent classification is a NLP task that identifies the purpose of users behind his input, like whatever the user is giving the input, what is his expectation is proposed here. And um it handles both text and voice inputs. And the confidence score can be measured as shown here, like the softmax based probability. This is the formula which I have used, whereas pi is probability for class I, and zi, it is the logit score, and n is the total number of intent categories, and I have used 9 intent categories, so here it is 9. And class is nothing but the input. And confidence is also calculated using these things only. And confidence threshold values are different, like for high confidence, when we get a more than 80% or equal to 80%, then it is considered as high confidence. Yeah, that means it is the predictions are correct, or are up to the mark. And when the predictions are between 60% to 79%, it is a moderate confidence. That means the prediction is true, but there are few cautions, or else few needs, like few errors are there. And when the prediction is less than 60%, it may be unreliable, or it is not true. Next, data augmentation. Data augmentation is used to improve the performance and robustness of the model. And this data augmentation will create different samples for one input, like for one data. And intent specific augmentation is similar to data augmentation, but here it creates different possible captures for one for one intent, whereas data augmentation will create captures for same data. And for example, for specific augmentation, you can see here, like add to playlist, like which I have used in my intents. This is one of the intent. We include different ways, like people talk about adding songs, playlists, or music, so these all comes under that. And next, so these are my outputs. I'll show you it practically. So my conclusion is that uh, my conclusion is to introduce identify, that is intent classification, for both understanding voice and text inputs. And I have used BERT along with data augmentation to achieve strong and consistent results. And it also supports multi-modal inputs, which makes high useful of real-time applications. Like in real-time applications, we can use it more, like AI, virtual assistants, customer service, and smart devices. and the future scope is that we can extend it in multiple languages, and we can use techniques for adopting new domains, and we can reduce the interference of latency in real time optimizations, and we can do it as a distributed training. And these are my references where I have searched and used, referred, and this is my presentation, and I'll show you the output. So I have started running this Streamlit. So I have started running it here already. So it gives me this output. So here this is the information, the left side whatever you find, that is the information about my project. This is the model information. So it is trained with 5-fold cross validation. Or like, what is 5-fold cross validation means? It is a technique used to evaluate how well a machine learning model performs on unknown data, and it is like, what it will do means, it will divide the data set into 5 equal parts. Those parts are nothing but 5 folds, and the model is trained on 4 parts and tested on the remaining 1 part. So this process is repeated 5 times, each time using a different fold as the test set, and the final result is average performance of all these 5 rounds. And these are used to check consistency and reliability of the model, and also to avoid overfitting by testing multiple data splits, and gives a better performance compared to single train split data. And as I told you in the PPT, these all are I have used, and it also shows the confidence threshold. It will show the history, it will show the visualizations also, and so since the user may not know like what inputs he can give, since it is a small data set, so I have given example testing samples here, and you can filter it based on each thing. Like, you can select any one of the intent from here, or else you can keep it as all if you want to test any random thing. Then when you click on use random sample, it will give the sample input and also the output what it need to give, along with the average confidence, the confidence, and the predictions, and along with intent distribution. So everything it will represent. So first I will show you the text. When you want to give some text, so I am typing whatever he has, like whatever it has given. So umbrella need to be replaced later. Okay, so I am asking that, does the umbrella need to be replaced later? So I am clicking on classify text. That means it will go show the intent, which intent it belongs to. Then see, I got the same thing. Since umbrella, when we'll carry umbrella during rains, and it is related to weather, so it is giving us get weather, and the confidence is 72.67. that means it is moderate confidence, and the average confidence is 78.36, And this is the intent distribution, like what are the chances of intents to get, and more chances are for get weather only, so share they have given that. So it has given that, sorry. And these are my prediction histories, like previously what I have given and what I have used, it is giving that. And next, like it is including the sample examples also. And confidence over time, like what is the confidence it is giving, like it is graphically representing based on that score. And this intent distribution also based on that pie chart, it is representing the representing graphically. And you can get how many random samples you want. And now I'll text with voice input, so I'm giving the voice input, can you help, okay, can you help. So it has given the predictions, it has given the output like this. So I'll give you one more example. I would like to add new jazz tracks. So it is giving the appropriate output. And so this is my presentation. Thank you. And what I have implemented more in this is, along with text inputs, I have given the access to voice inputs also, so you can find the output along with voice inputs and text inputs. And the comparatively the accuracy is more, and the performance is more, uh, and the consistency is also more. So this is my project. Thank you.